Hi everybody. For part 2, we have simple variations of functions or functions and transformations. Transformations means translation, symmetry with respect to a line, etc. Example 1, if f of x equal 2 power x, and c is the curve of the function f, we must deduce the curve c prime of the function g of x equal 2 power x plus 1. The graph c of 2 power x is the graph dotted has x prime x as horizontal asymptote, passes through 0, 1 and tends to plus infinity if x tends to plus infinity. Now for c prime, we have g of x equal 2 power x plus 1. C prime is raised vertically by 1 unit. We add 1 unit from each point on C. We obtain the graph C prime of G. C prime has the horizontal asymptote y equal 1. C has x prime x. We add 1. So y equal 1 is the asymptote of C prime. So the graph of G is raised by 1 unit vertically. From this point, for example, we add 1 to obtain a point of C prime, etc. So we can deduce the graph C prime of G of x. Example 2, consider g of x equal 2 power minus x equal f of minus x, where f of x equal 2 power x, the same function. In general, the curve of f minus x is the reflection in the vertical axis of the graph of f of x. If C is the graph of f of x equal 2 power x, then the graph C prime of 2 power minus x is the symmetric of C with respect to y prime y. This part is the symmetric of this part with respect to y prime y, and this part is the symmetric of this part with respect to y prime y. The graph C and C prime are symmetric with respect to y prime y. Example 3. Let g of x equal minus 2 power x equal minus f of x. The graph of g is the symmetric of the graph of f with respect to x prime x. C and C prime are symmetric with respect to x prime x. In general, if we have two opposite functions, f of x and minus f of x, for the same x we have two opposite values of y, of f of the function f and g. So the graphs are symmetric with respect to x prime, with x prime x. F of x passes through 1, minus f passes through minus 1. Now we define the inverse functions. Let f be a continuous and strictly monotonic on the interval I equal interval AB. Strictly monotone, we have two cases, f strictly increasing or f strictly decreasing. Or if f is strictly increasing on the interval AB, we have the image A, image f of A, the image of B is f of B, then f is a mapping from AB to the interval f of A, f of B. If A less than B, f of A is less than f of B. But if f is strictly decreasing, the second case, if A strictly less than B, then f of A is strictly greater than f of B. So f is a function from AB to f of B, f of A. f of B is less than f of A. If f is strictly monotone, we say that f is a bijective, bijection, or is bijective from I, the interval I, to the interval j equal f of I. F of I mean f of a, the interval f of a, f of b, or f of b, f of a. In this case, if f is continuous, strictly monotonic in the interval ab, f admits an inverse function, noted f minus 1 over f of I. F of minus 1 is a function from f of I to I. The image of x by f is y. The image by f minus 1 of y is x. In general, we can write y equal f of x, with x belongs to the interval I equal a, b, is equivalent to x equal f minus 1 of y. Y is the image of x by f. X is the image of y by f minus 1. For the next time, we study 3 examples. 1, f of x equal to x. The image is a straight line. We must prove the inverse function. 2, f of x equal 2 power x. And 3, f of x equal radical 1 plus x.